Alright, welcome back to the MCAT grind. We have Chapter 10, General Chem of Acid and Bases. So starting off with the definitions, Arrhenius acid is one that has H to it, and Arrhenius base has OH to it. Now, that's the least general, that's only very specific definition, and we're moving on to Bronsted-Lowry definition, which says acid donates the protons, whereas the base accepts the protons. The Lewis acid is the best one because it says electrons, and you can draw out Lewis structures quite easily. It says that acid accepts the electrons, and whereas the base donates the electrons. We have pH, denoted by negative log of the concentration of H hydrogen ions in there. And pH plus pOH must always equal to 14. And the concentration of H and OH multiplied together is 10 to negative 14. And we have this general equation of how a generic acid can dissociate into H3O and a base. H3O is basically just H2O but plus another H hydrogen, and you can think about canceling that out, just extra proton on the other side. We have the generic equation of Ka of H3O on the other side times acid, or times the base over the acid. That gives you the general dissociation constant. If you have a strong acid and a base together, then the curve is going to look like this as you add more and more base. Right? The pH is going to go up, but once you reach the equilibrium point here, it's going to shoot straight up. If you have a weak acid, then you're going to start shooting up a little earlier with addition of base and have a higher end result. In general, if you want to convert pH from a negative log, you can do it quickly by using m, bring down exponent down here, and minus 0.n. That's the nature of how to work easier negative logs. Buffer works in generic solutions, where just like how sodium, which is in carbonate buffer. Basically, buffer consists of a weak acid and a strong base, or a strong base, or a strong acid and a weak base. Basically, it makes the solution not change the pH a lot, even though you add certain concentrations to it. And generic Henderson-Hasselbalch equation is pH equals pKa plus log of the base over the conjugate acid. Alright, that's pretty much it.